Okay, so back in section 3.3 in the what color packet? Was it green? No, the green's a new one. I think it was the salmon color one where we talked about polynomials. There were some exercises that asked you find the domain of square root functions. And what you want to remember about that is I can't take the square root of a negative number. So those pieces are not included in the domain. So I gave you, in this example, I gave you, so this is, if I were to expand this all out, wouldn't this be x cubed plus a bunch of other terms? So basically I'm asking you to, what you're taking the square root of is some cubic polynomial. So what's the easy way to figure out the domain? Well, what we did back then, and what I encourage you to learn how to do, and that's why we're doing the review, is you find the zeros. Well, I know when x equals -10, it's equal to 0. I know when x equals 3, it's equal to 0. And when x equals 15, it's equal to 0. And then what I encourage you to do is make a little number line, and we're going to write those zeros in. So 3 and then 15. And then we tested values in each of these intervals. So if I take, I don't know, what if we did -20? -20 is in that first interval, right? So -20 plus 10 will be a negative number. -20 minus 3 is a negative number. And -20 minus 15 is another negative number. So a negative times a negative times a negative is negative. So anything less than -10 is going to be a negative number. So then I'm going to pick a number between -10 and 3. Well, 0 works pretty well for that. So then what we're going to do is we're going to substitute 0 in for just the polynomial part. I don't really care too much about the square root yet. I just wanted to find what's happening to the polynomial in those ranges. So if I drop in 0 for x, 0 for x, 0 for x, I'm going to get a positive 10 or a positive number, and a negative number, and another negative number, and a positive times a negative happens to be positive because the two negatives cancel out and we get a positive, right? We're multiplying. So that works. Now we'll pick a number in this range. I don't know, how about 4? How about if we substitute in 4? I mean, it could be anything. It could be 4, or we could be 10 if we wanted to. I just decided 4 works well. So 4 plus 14 is a positive number. 4 minus 3 is a positive number. 4 minus 15 is a negative number, and I only have one negative, so when I multiply those, that's negative. Now I'm going to pick a number bigger than 15. I don't know, 20. We could do 16. We could do 100 if we wanted to. But what that's going to give us is, let's say we use 100. 100 plus 10 is a positive number. 100 minus 3 is a positive number. 100 minus 15 is a positive number. And multiply 3 positives, we get a positive. So remember, we can't take the square root of a negative number. So anything less than -10, so if we did x is less than -10, that's not in the domain. But from -10 to 3 is, and it's inclusive, hard brackets, because we can take the square root of 0. The square root of 0 is 0. So these zeros work. We can do that. And then we got to skip over because between 3 and 15, the value is negative. We can't take the square root of that. So we got to skip over that. So I do a little u for the or. And then we can go from 15 to infinity because it's positive there. And of course, we are open at infinity because only Chuck Norris can get there. So there's the domain of that polynomial function. And I encourage you to do that same kind of thing. And just as a check, what I did do, and now if you just give me this, you're only going to get 2 of the 4 points, or 2 of the 5 points. But if we look at the graph of that radical function, I see from -1 to -10 to 3, it works. And then we said that was part of the domain, and then from 15 and beyond. And it skips over the 3 to 15, and of course it skips over the less than -10. So there's how that graph works. Okay. Now we could, let's see. If I just wanted to be concerned with the polynomial graphically now, do you see how, let's see, let me zoom out. Let me stop this video a minute and I'll tweak the window. So the blue graph is the polynomial that's underneath the square root. And do you see how when it's left of -10, well, it's not, when it's left of -10, you see how the polynomial is below the x-axis, which means the y values are negative, which corresponds to what we did on that number line. And then between -10 and 3, the polynomial is above the x-axis, which means it's positive, which we can take the square root of, and that checks. And the same thing's happening between 3 and 15, where the y values are negative. We can't take the square root of that. And beyond 15, the polynomial is positive. So that's it. So, I mean, if you wanted to, and you were a little confused about the analytical thing, how I knew those were positive, negative, so that wouldn't be a bad thing for you able to do, especially if you're thinking about calculus. You could just graph the polynomial and then fake it and say, well, between less than -10, it's negative. Between -10 and 3, it's positive. And you do the same thing with the number line without having to substitute in values. See what I mean? So hopefully this will help you do that one new problem, and everything else is a repeat from last week, just different values. So I'll stop this video and get it up, make it available for you.